Shall we start? Good morning, sir. Good morning, everyone. So, today is the day 4 of our workshop. So, we are going to start the first session, the first lecture of today's. The title is Sensory Evaluation and Consumer Acceptance Testing. And this workshop, this session will be taken by Dr. Vivek Kamampati, sir. So, please start.
Sumi, am I audible?
Yes, sir, you are audible, sir.
Already introduced. Shall I start?
Yes, sir, you can start.
Okay. Thank you, Shumi.
Thank you.
I request participants to join on time. Why? Because it will be delaying the second session also. Right. So that's why I request all the participants to join on time. Okay. Anyhow, we will. Today is the day 4 of our certificate program. So today you will be learning about the sensory evaluation and consumer acceptance testing. So far you have learned about why we need to use food analysis in the industry, and then you learned about how to do the sampling. If you see, each and every lecture is systematically designed in a flow. Okay, everything is well connected. And you learned in the first day, you learned about the macro and micronutrient analysis, the demonstration you have seen. Then one step further, you saw chromatographic techniques, spectroscopic techniques, and then the practical demonstration. In the yesterday's class, you learned about what are the different types of food additives, how to calculate the how to quantify the additives using whatever spectroscopic or chromatographic techniques that you have learned on the day 2. Today, in the yesterday's third session, you learned about rheological. So what is rheological properties in the food, and you learned about the thermal analysis, DSC analysis, and all. It can be used for identifying several food additives also, right? And then today we'll be discussing about the sensory evaluation. So these are the learning objectives. uh, After completing this particular lecture, you will be able to learn, right, importance of sensory evaluation in the food analysis, food industry. Then understand the different types of sensory test available and where to use those things also you will be learning. Then you will learn about the panel selection and training procedures also. Then you will explore some data analysis and what different types of data analysis are being done in the sensor evaluation. And then consumer acceptance tools, right? So this is the introduction of sensory science. All of you know about what is sensory. It's a systematic assessment of food properties perceived by all the senses, right? So there are 5 different senses we have. If a food is given, how do you analyze? You will first see whether the food appears good or not, whether it is fresh or not, right? If there is any spots on the food, or maybe if there is any you know some problem, right? If it is moldy or rough skin, something is bruising is there, then you will not consume that food, right? Then sometimes you will use your hearing senses, something like when you purchase coconut, you will tap it, right? You will tap it with your hands to check the sound, how much water content is there. Similarly with the watermelon, And the sense of touch also same thing. You will just touch the texture of the material. So how smooth or how rough the food is before consuming, right? You will catch. You will just hold the food and then you will analyze. Your mind is smart enough to analyze. How much biting force you have to give. If you are eating nuts, then how much biting force is required, right? Similarly for smell also, if you are going to coffee shop, you'll get a nice odor of coffee, right? It will attract, the smell will attract consumers to consume any kind of food. And tongue, definitely it's the ultimate thing. Taste, if there is no taste, just before consumption, then we'll not feel like eating that food, right? Basically what it does, it these five senses, right? Either we can use some of the instrumental methods and correlate with the five senses, right? So it complements the instrumental and chemical analysis essential for some kind of product development and quality control. So how this will be beneficial for product development in the laboratories or in the industry, if you are changing the composition, so then you need to go with the sensory analysis just for increasing the shelf life or increasing the nutritional profile. That is not sufficient. Whatever the food, if you develop a very good protein rich or fiber rich or whatever the great food that you develop in your lab, if it is not fit for consumption, then what is the use, right? So that's why it's very important to go with the sensory analysis before launching a product in the market. These are some of the importance in the food industries. You can see the sensory analysis, it guides product formulation and reformulation. Reformulation is very much important. Sometimes what will happen, the developed food, okay, whatever the formulation that you are using to develop any kind of food material, it may be liked by some age groups, it may not be liked by some age groups, right? The same food item that I am telling. So for those people, you need to consider what are the different sensory attributes this particular age group is liking. Similarly, for the second age group also. Accordingly, you have to develop and reformulate the existing food product to consider both the age groups, right? Then supports marketing and branding strategies. Definitely, the sensory analysis, it will support the marketing, right? For the marketing people, they can easily discuss with the wholesalers or retailers or maybe consumers that this particular product is superior quality, it is of a great taste. Quality, the quality, you have two things. The first one is nutritional aspect also comes under quality, and the sensory attributes also coming under quality, right? Quality is very much important when it comes to the new product development. This will ensure the customer satisfaction. If the customer is satisfied, what he will do, he will purchase that particular product repeatedly. This is the secret of any kind of business, right? If I am going to start any food industry, I will release a very good product initially for 1 year. I will get a very huge, customer base. After that, if I decline the quality, what will happen? Slowly, my consumer base will be declining. So, in order to sustain in a market, so normally, what businessman will think, he wants to sustain in the market for longer duration. All right. So the businessman, he will not think that, okay, I will start the business today and after 6 months I will close the business. Am I right? So that kind of repeat purchase will create confidence in the R&D team or maybe the marketing team to sell their products easily. The market penetration for that particular product will be very easy. Then this particular sensory, it validates instrumental data correlation also. I told you, right? You can take you can get the nutritional profile, you can get the sensory data, then you can correlate both the things, you can correlate. Okay, so in that way this particular sensory science is useful in the food industry. When it comes to the sensory attributes, every time we say sensory science, right? Sensory science is, it comprises of these attributes. These are the, very essential attributes that we consider for sensory signs. First one is appearance. Under the appearance, we have color, shape, surface. Under aroma and odor, right? Flavor also sweet, sour, bitter, umami. Texture, aftertaste, and mouthfeel. If you see, this is very simple, but 90% of the time we take the sensory analysis using these things, right? But there is a sensory vocabulary available for each and every product, right? So like this, using these normal sensory attributes, wine sensory will not be done, beer sensory will not be done. Okay, so you need to have a special sensory vocabulary, or maybe tea tasting. If you can, I don't know how many of you heard about this one. Tea tasting is very much important. Coffee tasting is also very much important. It is a very huge market. If you can identify the quality of the tea that is, being procured from the farms, tea farms, tea estates, right? If you can identify the quality, only the sensory people can identify which quality of tea is good. Similarly, for the coffee also, different quality are there, right? Different quality beans are there. So for that particular, these are coming under the plantation, this one, right? They have separate sensory vocabulary. They have separate sensory vocabulary means what? They have a chart, right? They have a chart. They will roughly divide. They will roughly divide the sensory attributes, the broad aspects here, and then they further divide those broad aspects into different sub sensory attributes, right? We'll try to study that one. Similarly, for odor, you can see here, we saw here, right, aroma and odor as the two things. If I ask you more about the aroma and odor, you can tell maybe something pungent or scented smell, but you have so many subcategories: fragrant, perfumed, floral, aromatic, earthy smell, musty smell, acrid smell, scented smell, pungent smell, like that. In the taste also, you have different types of subcategory attributes, right? Texture also same thing. If you want to become a sensory professional, then you must be aware of all the sensory vocabulary. Then only why? Because the sensory experts are paid hefty amount of money for tasting their food product. These companies are willing to pay hefty amount of money for the sensory professionals. But unfortunately, in our country, there are very few sensory professionals are available because of lack of training, right? Because of lack of awareness on this particular field. So this particular sensory science is very vast, and it has a lot of opportunity. Difference between analytical and affective test. In the sensory analysis, you have two different things. One is analytical thing test, and the second one is affective test. What are those things? Analytical test means objective measurement using a trained panel, right? In the analytical techniques, you will use a trained panel. Effective testing, you will not use a trained panel. Consumer preference, right? Consumer nowadays, in the research article, you can see normally we publish, if you are dealing with any kind of product development, or any kind of sensory data that you are incorporating in the research article, these articles, they sometimes they ask what type of panel you used during the sensory sense. Is it a trained panel, or is it a semi-trained or untrained panel? If you use untrained panel, right, if you develop a product and you take the sensory score from your colleagues, or maybe your classmates, or your teachers, or your subordinates, whoever it may be. If you take the readings, you get the data from untrained panel, then you have to change that into consumer preference, not the sensory study, right? Consumer preference word you need to use. Here in the analytical test, small trained group of panelists are used. In the effective test, large untrained groups are used, right? Conducted in controlled lab environments. It happens like this. Analytical test, it happens like this. Small group of sensory trained panel will be giving the score for analyzing your product. Whereas in the case of effective test, it is linked with the market. So you develop a product, you just give it to the random people, and then you get the score. Normally it is associated with large and untrained group, right? Focus on describing and quantifying sensory attributes. For analytical, for effective, focus on liking, preference, ranking, and acceptability. You just ask whether this food is good or not. Can we, just you will ask how much score you will give out of 1 to 5, right? If the food is good, they will give 5. If the food is not okay, then they will give 1. Is it like, right? Results analyzed statistically for differences. Results analyzed for consumer trend. This is the main difference. These are two tests. Under these two tests, you have many subcategories. We'll discuss those things. But when I say sensory science, analytical test and affective test will be there, right? These are the key differences. Sensory testing environment. If you want to go with analytical test, this is the environment you need to create. Sensory labs are very much important, right? Uh, you know, this is ordinary sensory lab. Nowadays people are using screens, computer screens, to take the data in order to avoid the biasness. The panel member will be sitting here and they will enter the data. Why? Because it is not possible to manipulate the data again, right? It will directly go to the industry. That way the sensory labs are being developed. This is the normal design for any kind of sensory lab setup. Okay, you can see this is the briefing room, where the meetings will happen. After that you have a sensory booth, right? B is the sensory booth. Okay, so this particular area is for the serving purpose. Okay, and then you have this preparation area. People will prepare and then the serving area will be there. Sometimes you can also give in this particular, there will be a small opening here. Through that opening also you can serve the food, okay, to the panel members. And then you have different designs is given. You can see here the design of sensory laboratory. It should have controlled lighting and temperature, noise-free booths for individual evaluation. There should not be any disturbances. Lighting should be perfect. Okay, then neutral colors to avoid bias. Why? Because if you are using the white color, if you serve any red sample or any kind of sample, the same sample served under different colors will have a different score. That's why use the neutral colors to avoid the bias. Then proper sample coding and randomization is important. If you are not coding your sample, then you will get an inaccurate results. Am I right? Then here, sample preparation and presentation. How do you prepare the sample for sensory testing? Standardized size is required. If you are if you want to evaluate the sensory analysis for get the sensory score for bread, what do? You will not give the full bread, right? There are some standard size available for the sample preparation. Maybe you will give one slice or two slice, or maybe taken at different junctures. If you want to give cake, you will give small cupcake, right? You cannot give very big cake, okay, used for birthday parties. Or maybe you cannot give very big food item for evaluation, right? Why? Because this particular part will have a different score. The same product, different parts will get a different score. So you can take different samples and you can give it at different points. You can give it to the sensory panel, they will evaluate. Randomized 3-digit code is normally used. Okay, now something like 235 or any kind of 3-digit code you can use. Equal serving utensils and containers, these are important when it comes to. This is the model picture for sample preparation and presentation in the sensory analysis. Panel selection. How do you select the panel? This is very much important. If you want to become a sensory professional, then you should have a sound health without any problem. You should not have asthma, or you should not have tobacco chewing habit, or you should not be a alcohol consumer. There are so many requirements are there. To select a panel, they undergo stringent screening procedures, right? There should not be any allergy or taste or smell impairment, interest and commitment to the training. They should have a patience, to determine the sensory score. See here, next one is panel training. After selection, what you will do, you will select the panel, then you have to train the panel. You cannot use the panel directly, right? You have to train the panel about the terminologies used in your sensory lab. What type of terminologies you are using. Each and every sensory lab will use different terminologies and they have a different score sheets, right? They have a different score sheet. So you need to give some kind of orientation on scaling or terminology. Then calibration with reference samples. You have to give some reference sample and you need to explain them how you are going to do the test. Then reproducibility and discrimination training. These two are very much important, right? Because this, if you take the perception, everything is based on the perception, right? So here, panel will be sitting here, and they will be using all their sensory this one to give scores. Okay, the key areas you need to cover. What are the objectives of your study? What are the methods that you are going to use? And what are the performance indicators? And are you using any kind of softwares to enter the value or do some kind of statistical analysis? Are there any corrective action? These things you need to clearly inform the sensory panel. Some ethical considerations like informed consent and confidentiality is also important. Before starting a sensory, after training the sample, you need to take the consent from the sensory panel, right? Then avoid bias through blinding. You should not disclose any brand name because if I say Cadbury, first thing comes to your mind is 5 star, right? If your panel is giving score for similar five kind of 5 star chocolates or maybe similar kind of product, then they will have bias towards giving the score. And then fair compensation and safety assurance is also very much important when it comes to sensory training, right? And then the types of sensory test, classification of sensory test, classification of sensory test. In this, you have three different classification: discrimination, descriptive, and affective test. Okay. What this discrimination test does, it detects the differences, right? It only tells you which product is different. Descriptive test means quantify the attributes. Affective test will measure the preferences. Okay, here you can see, you will tell the panel, right? So taste means, if the 5 score means extremely sweet, very sweet, or sweet, or slightly, if you are giving any kind of product, you will tell taste. If I'm going to measure taste, and these are the 5 things I'm considering. Flavor or aroma, these are the 5 things, right? The subdivision you need to clearly inform to your panel members, right? So sensory evaluation, normally consumer testing and descriptive analysis. I told you consumer testing, no, descriptive analyzing, two different things that predicts the consumer acceptance. So normally you are predicting the consumer acceptance. Informs on, it what it will do is informs on new ingredient processing technology to improve the quality of the sensory attributes of the product, right? Then if we see under the different test, and these are some of the types of sensory tests. Paired comparison test, dual trio test, triangle. We'll try to learn each and everything. In the ranking test, you have rank test, single sample test, two sample test, multiple sample test, hedonic scale. All these things are following. Sensitivity and descriptive test. Discrimination test. Here, if you see, compare the two or more sample for detectable difference. You will just tell the difference. Panel trained to perceive minor variations. right? You will be given like this, 3 products. You will be given 3 products. You will tell which one is different. If 462 is different, you will just give the score. I know you will write 462 is different. You will just ignore 2 other sample, right? In the triangular test, you have, so this is the triangle. Normally, the sample will be placed like this, okay, in a triangular manner. Although the 3 products looks identical, but there will be a difference in only one product. 2 products will be same. You need to identify the different product. 3 sample, 2 identical sample and 1 different sample. Panelist identify 1 odd sample, right? Odd one out. You need to give odd one out in this particular thing, used for ingredient change validation. So, the triangular test sheet looks like this. Okay. Depending on the sensory lab, this will be varying, but most of the time it looks like this. Name you have to give, name of the panel evaluator, date, which test you are using. Please assess the aroma and palate of 3 wines and circle the code of the sample that different from the other 2. Circle the sample which different from the other 2. If there is no difference is perceived, you must guess. This is also important, right? In the set 1, you will tell this particular panelist, okay, Sally, she wrote the name, date. Then she, for her, 347 is odd compared to 212 and 642. Similarly, for the second panel, you will take 347, 347, 347, right? For the last panel, you see, for her, 212 found different, right? So you just eliminate. This is the 5% error. It comes under the 5% error. Okay, if out of 195 people are giving 347, then you need to consider 347. Remaining 5 you can ignore, right? That's what probability says. Okay. So in this one, this is computer generator. You can just, instead of circulating the sheets like this, you can ask panel members to click on which sample is different. Next one is duo, trio, and paired comparison test. Duo, trio test means what? Reference will be given, right? Reference and 2 samples match to reference. So here 3 samples will be there. 2 samples are same. One is reference. You need to match 1 sample. 2 are different. You need to match this particular. If this is a reference, similar to reference, 1 will be there, right? You need to tell which sample 352 is matching with the reference, or 407 is matching with the reference. This is the reference, sorry, reference, right? So here also same thing. This is the reference. Which sample is matching with the reference, you need to identify, right? In the paired, which 2 samples are sweeter or crisper? This is very small, easy kind of sensory evaluation. You need to identify which sample is sweeter. You can see in the duo-trio test, there are 3 hops cone palette samples for you to evaluate in each of the 2 sets. In each, one of the coded sample is the same as the reference, and one is different, right? As I told, one is different. Asking the panelists to evaluate the reference first, then coded samples in the sequential presented, right? So similar sequence, 847, 603, 847, 603. Similarly here, there are 2 apple slices sample present for you to evaluate in each of the 2 paired tests, 2 paired sets. Taste each of the coded sample in the set in the sequence presented, left to right, beginning with set 1. Okay, 2 sets are given. Within each pair, circle the sample that is sweeter. Okay, this is sweeter. Proceed the next set and repeat the sequence. See here, you can see, different codes are used. In set 1, different codes are used. Set 2, different codes. As a panelist, I do not know 964 is equal to 836. Am I right? You need to identify. Okay. In the paired preference sample, you have evaluated the two coded hops, cone samples in the sequence present from left to right. Okay, you need to identify which one is the different 284 or 596, whichever is different, you need to identify. In the descriptive testing, quantify specific sensory attributes, right? This particular descriptive test, it quantifies the specific. If you are given to taste the wine, you will tell the aroma of the wine is good, or maybe you will tell the smell, or maybe the after mouthfeel, or maybe after eating the mouthfeel was good. So you can quantify. Requires highly trained panelists. Data used for product profiling. We'll discuss about product profiling. This QDA is very simple, and this is most widely used. Attributes defined by panel. Okay, in the QDA, all the attributes will be defined by the panel. So panel members will define. They will say, right, what are the attributes here? For example, you have fish flavor, fish odor, saltiness, spiciness, color, hardness. These are the attributes. These attributes will be given after seeing the product. Okay, after seeing the product, you need to guess what are the different attributes you can give. And intensity rated on unstructured scale. This is the unstructured scale, right? Unstructured scale. Extreme, very strong. You will just say fish flavor. You will tick it here. Okay. What is 5 here? Moderate fish flavor you are getting in the sample. Fish order. Okay, number 3. What is slightly? You are getting the fish order. Frying. How much it is frying? Extreme fry, maybe. Okay. Like this, you have to use this particular QDA chart. Produce a sensory fingerprint. This is the sensory fingerprint. What do you mean sensory fingerprint? If suppose for a product, fish product is given, processed fish, and you found that these are some of the attributes, right? And then in this particular thing, you get, okay, this fishy flavor is absent. Spiciness is absent for all the panel members. Oiliness is absent. Then what you will do, you will ignore these three things. In the next sensory evaluation, you will only consider fish odor, saltiness, hardness, fry. Okay, this is called as the sensory fingerprint of profiling. See here, 4 different samples are given. Okay, 4 different samples are coded with the coded terms. Then identify. You are asking panelists to identify what is the score given for acceptability, overall acceptability. How much score for juiciness, texture, flavor, and appearance. This is not for a single panelist. 10 panelist score will be combined together and average is made here. Okay, see, this is 1, 2, 3, 4, 5. Here 5, out of 5 scale you are asking, right? Similarly for the other sample B, C also same thing. You are identifying which sensory attribute is dominating. Here, can you identify which sensory attributes? Appearance is dominating here. Appearance got the good score here, whereas here color got the good score. General acceptability also almost, this is also high. Whereas in the case you see general acceptability, product RP, product 2 is having good texture here. Am I right? So here the good color is for LNFP. The first sample has the good color. Here in the appearance, NF means first sample is appearing good. Like this, you need to get some information from the sensory data. This is the flavor profile analysis. I told you, right? The flavor charts are used. Okay. For chocolate flavor profiling, you see here it's just a chocolate, right? But you see chocolate flavor profile, we say it is sweet or it is dark, or no, like that only. If I ask you people, you tell the different quality attributes for the chocolate. What you will tell, you will just say color should be brown, and then this is taste should be sweet. How sweet you do not know, right? And the texture should be smooth, and you should not break. So many things you will say, right? But actual profile, if you see, In the spicy, okay, category, you have coffee taste, vanilla taste, cinnamon, black pepper is being added in the chocolate, all these things. In the nutty, you see hazelnut, walnut, what kind of nut taste you are getting. Caramel, what type of, this, these are subcategories. Fruity, which fruit, is it a strawberry, berry type? Is it a tree type? Is it a tropical fruit type, dried fruit type, raisin smell, or how, what kind of, attribute, what kind of, texture or feel you that you are getting after eating this particular chocolate, right? Similarly, earthy flavor, floral flavor. This is the chocolate. Similarly, you have for coffee also, coffee. Similarly, you have for some different food products also. This flavor profile analysis identifies dominant aroma and taste notes, useful for the flavor development and matching purpose. Purpose of flavor profile analysis to provide a detailed sensory fingerprint. This is very much important, right? Fingerprinting is very much what type of attributes are involved in our product. The type of flavor notes present, you will identify sweet taste, fruity taste, or whatever, and its intensity. Sweet means how intense sweet it is. Their order of perception, right? Which appears first. The overall balance and aftertaste. All these things will be known after performing the FPE. See here, similarly, this is for other, other product. I think this is for, different honey or maybe, some other product. Lactic taste. See here in the profile, you can see fresh, milky taste, buttery taste, sweet, stale, sour. All these things are coming under the lactic profile. Okay. Similarly, for other yeast, mold, and then feed, so many a small trained sensory panel is used. They know these things. All of us, we do not know. We are not sensory experts, right? We do not know about all these things, but these trained panel members, they know each and everything. Normally, 4 to 6 member is a team. They give the score for different products who can identify and agree on flavor descriptor to discussions and consensus. Right? They discuss. Okay, 6 people they discuss on this chart. Okay, I'm getting moldy flavor. Okay, it's a musty. Somebody says no, it's not musty. It's yeasty flavor. So they will discuss and they will come up with a conclusion. These are some of the steps in conducting a flavor profile analysis. Sample preparation is very important. Under controlled condition, you need to do. Parallel training is also important. Bitterness of coffee, they should know if they are identifying, flavor notes of coffee. Flavor identification, they should be able to identify the different flavors present in the chart. Intensity rating, how intense the flavor note is, 0, 3, 6, 9, strong or slight note. Profile development, the final profile, flavor profile is expressed graphically using the radar plot or flavor wheel. This is the flavor wheel. FPA evaluation sheet looks like this. Sample code will be given. Date you need to enter, panelist who is, and then underneath signature is required. Flavor attribute you will tell sweetness, bitterness, acidity, roasted note, and then aftertaste. In the description, sugar-like taste. In the sweetness, what type of sweet? Is it a fruity sweet or maybe some other sweet? Okay, you will tell here, you will write down it's a sugar-like taste. In the bitterness, what type of bitter? It's a coffee-like note. Acidity means it's a lemon kind of, you need to write down what type of attribute. Roasted note means how roasted, toasty aroma. Okay, or any kind of, bread toast or any kind of aroma. Then you need to give the intensity. Intensity means sugar-like taste. How intense it is? Is it a 2? Very intense means 9. Similarly for all, right? So you got number order of perception, second order. This is the first order because you get 9 here. then it will become first preference. Second preference means must have got 8. Third preference, fourth preference, and fifth preference. If you are going with consumer, normal consumer preference testing, you will see 1, 2, and 3 are very much important. 4 and 5, it's fine. You get the score, but it's not significantly contributing in this sensor evaluation. First, second, and third are significantly contributing. This is how you need to read. What are the key advantages here for qualitative and quantitative? Qualitative means non-numerical, just a linguistic words. Excellent, maybe a good product. It's a sweet product. But quantitative means numerical, how good it is. Out of 10, 9 I'm giving, like that. Purpose, explore ideas. Is this in the qualitative, you measure, test hypothesis, identify patterns, right? Interview transcriptions will be there, survey results, then identifying themes, typically smaller group, typically larger group for the quantitative to allow statistical reliability, right? The next one is texture profile analysis. This is called as the texture profile analysis, TPA. If you see, if you give any sample in the texture analyzer, you will get this kind of graph. You have 4 strokes, right? First one is downstroke and then upstroke. You have 2 different downstrokes, 2 upstrokes, like this, right? The moment you kept the sample in the texture laser, the peak will be starting. Then it is called as the hardness. Then slowly it will come, and then it will hold. Okay, second cycle. This is the first cycle. After first cycle, we have some holding time. Then the second cycle will be starting. Okay, you can find out hardness, chewiness, coarseness, gumminess, measured by panel and correlated with the instrumental texture profile analysis. If you want to correlate with the texture profile analysis, you can do this. TPA parameters and sensory meaning. Hardness. What do you mean by hardness? Maximum force during first compression. Okay. Sensory equivalent, force to compress between the teeth, is called as the hardness. Cohesiveness, ratio of area under 2 compression to first. Degree to which sample holds together. Like this, you have different definition and sensory equivalents are there, right? Elastic recovery, resilience, chewiness, energy required to chew the solid food, adhesiveness, stickiness to tongue or palate, right? So from this graph, you can calculate all these things. Okay, the graph will, the software will give you the numerical value, then you can calculate using the formulas. This is the instrumental setup. You have probe. You have to select the probe. What type of probe you are? This is microstable model, and this is Brookfield's model, right? What type of probe you are using? How many compression cycles? What is the test speed that you have set? Sample shape, and then what is the temperature? These things are very much important when doing the texture profile analysis. Texture profile analysis application. You can see where you can apply, you can measure texture for all the food items. Okay, there is no limit. But you have to use different probes and different specification for that particular food material. The data sheet will look like this. After getting a value for any kind of sample, you will get hardness in newtons, cohesiveness, springiness, adhesiveness, gumminess, and chewiness. Like this, you get data. The next category is affective test. What is affective test? Mostly it is based on yes or no. Did you like the sample or did you not like the sample? Usually it comprises of 50 to 100 untrained customers. Realistic training environment is normal environment. There is no special lights or nothing is available. What is the purpose? You to know liking or disliking, preference between samples, purchase intent of that particular sample. Also helps food industries answer, do customers like the product or not? Which product do they prefer? Will they buy it again or not? This is the most important thing required for the industries, right? So this is very important. The next one is panel character. What is the characteristics of the panel? You can see here, large group of untamed panel members are required. Okay, number will be ranging between 50 to 300, maybe 100 you can use. Environment, real life conditions, market like or home use conditions. I told you, right? Normal conditions. Evaluation goal to obtain opinions, not the analytical data. Types of effective test. This hedonic test is coming under the effective test. Then you have preference test, you have ranking test, purchase intent test. Right? What is the purpose of hedonic test? Measure degree of liking. I request participant to mute. What is the purpose? Somebody is asking in the question, somebody is asking me to explain the QDA again. Okay, I will do that in the end. QDA. Okay, I will do that one. Measures the degree of liking. Typically ranges 9-point scale is there from likely extreme, dislikely extreme. In the preference compares two or more products. Ranking test order first rank, second rank, third rank to these products. Purchase intent means evaluates buying intention. What are the advantages? Direct consumer feedback you will get. Reflects real world acceptability. Easy to conduct and interpret the results. The evaluation sheet looks like this. Attribute you will have appearance, aroma, taste, overall this one. Panelist name will be there, code will be there, and then he will give appearance, how good the product appearance is. 9 or 8 or 7. Aroma you will give like this. Taste you will give like this. Texture like this. Overall acceptability like this. This is the panel 1. Similarly, you have to take this sheet from 300 members. So you will have 300 such kind of sheets. Then you will see for appearance, you will take the average. How many people gave 9 for appearance? You will write down, right? How many, how many people you will take the average? Suppose 9 is given for appearance by 200 people. Then appearance is fine. Majority of the people give appearance, right? 9, excellent. Similarly, you have to read for other attributes also. Hedonic scale is very simple. 9-point hedonic scale. These are the meanings of the numbers. One is dislike extremely. Second one, dislike very much. Dislike moderately. So like this you can conduct, right? It looks like this. Preference test. You will ask, taste each sample and identify which one is preferred. A is preferred or B is preferred. In the hedonic degree of liking, right? If for the children you will tell like this, you will give like this. Okay. For different age category, you can use symbols also like this, emojis, symbols. They will just select. These are linguistic terms, right? You are not quantifying. You are just saying whether the food is okay or not. You will ask likely extreme. You will ask which one you prefer to adults. Reference test, you see, compare multiple samples of orders, right? Paired preference. Under the paired preference, you have different types of preference test. Paired preference test, multiple sample preference, and preference ranking test. Number of sample given in this one is 2. 3 or more. 3 or more is given in this 2 category. Panelist task. Choose one based on your preference. Choose the most preferred. Rank in order. Third one, right? What type of questions you can ask? Which sample do you prefer? A or B? Which one do you like most? A, B, or C? Rank the sample from most to least preferred. These are the preference tests. When to use the preference test? When comparing two formulations, right? The product is same. Suppose you are developing, chocolate. Both are looking identical. Here you are using sugar, normal sugar, and you are using stevia or any kind of artificial sweetener. Then you will ask the panel members which one is good. Okay, you will not tell I have added stevia here, I have added sugar here to the panel member. You will just ask which one you like. When you want a quick consumer preference decision, then you have to go with this particular preference test, right? This is the sample evaluation sheet. You can see here instructions you will give, taste both samples and tick the one you prefer, sample A or sample B. Which one do you prefer overall? Sample A. Like this questions you have to give, right? Then you will collect the data from 300 members. Then you will go with the statistical analysis. Ranking test also same. Okay, based on sample, different samples you will give. You will ask the panelists to rank. Sample A, third rank. B, second rank. First rank or fourth rank. Whatever. Based on the ranking you will do. Which sample did you like the most? Here panelists will write B. Which sample did you like the least? C. It's like this. Difference between preference and ranking. What is the main difference here? Preference. You are asking for the preference in the first one, and you are asking panelists to rank. Ordered ranking of all the. That is the main difference. Okay. Data analysis in interpretation. Statistical. You can use ANOVA or t-test, student t-test for comparing. You can compare for mean comparisons, right? Non-parametric test like this Friedman test you can use, correlation you can use. Okay, principal component analysis also you can use. What is principal component analysis? This particular PCA will help us find patterns. If you have so many number of you, if you are collecting data from 300 people, analyzing it is different, right? Difficult. So if you use PCA, patterns, similarities, and difference you can easily identify. For it will tell us which principal components are dominating. This is the division. How many samples are falling here? How many samples are falling here? Okay, this we can easily identify. Reveals a relationship between samples and attributes. Example, you can see in sensory or instrumental data, you might have 10 samples of foods or beverages, each evaluated for 12 attributes: color, aroma, sweetness, hardness. In this particular PCA helps visualize how samples relate to each other. For example, which sample are similar or different? Which attribute drive those differences? You can identify using the principal compound analysis. The interpretation will be like this. Suppose 5 yogurt samples were evaluated for sweetness, sourness, creaminess, aroma, and thickness. The PCA will give you 60% variance separate sample by sweetness and creaminess. For under these two category, 60% of samples are falling. Suppose here this is sweetness and creaminess. 60% of the sample fall in this category. Principal component 2 says this is the major contributor, right? Principal component 1. The second principal component 2, 25% variance separates by sourness and aroma. Maybe here it may be sourness and aroma. Remaining principal components, PC3, PC4, PC5, because this is 85% combined together. Still 15% is there. 3, 4, 5 will give you the remaining 15%. Conclusion you can draw like this. Samples on the right hand side of the plot, sweeter and creamier. The left hand side are more sour and aromatic. Like this kind of interpretation you can get from PCA. What are the advantages here? Reduces large data into simple visual patterns. Reveals hidden relationships between samples and variables. Handles both sensory and instrumental data, useful for classification and quality mapping. Correlation. So what is the correlation here? What your data, how it is correlated. Okay, is it having a positive correlation? Is it having a negative correlation, or is it having no correlation? Okay, with texture versus instrumental hardness, you can say, right? If suppose I'm giving you any kind of food, you will chew and you will tell it is hard. The same food you will do with the instrumentation analysis. You will start correlating how hard it is. 1, 2, 3 you will give based on the One is correlated with 2. 2 is correlated with the numerical values, and then you will see the trend, positive or negative correlation. Color also same. Applications, here you see sugar reduction in soft drinks. If you know how to perform the sensory analysis, you can reduce sugar in the soft drinks. Right? Nowadays, 0 calorie Coke, 0 calorie Pepsi, 0 calorie 7 Up, all these things are coming to market. You can see only the branded, uh, these brands are coming up with a new formulation, not our Indian products or not any other products. Everybody likes this product, right? There is nothing wrong, but here reformulation with stevia sweetener. In the first class, I showed you, right? Zero Pepsi, the labeling is some artificial lactulose is being used as the sweetener. Stevia or any kind of sweetener you can use. Using triangle and hedonic test conductor, you can identify how much sweet or whether the product is acceptable or not. Which product is different? You can say if you are developing, you want to correlate with the Pepsi, you will say which product A, B, C in the triangle I told, right? Which one is different? Results, no significant difference. Then shelf life evaluation of the snacks, the same thing. Okay. Then if you are developing a yogurt, right? Then you can go with the descriptive profiling, flavor profiling. Then sensor evaluation, quality control. This is very much important because quality control people, they will go for the routine testing. If sensor evaluation is integrated with the routine testing, batch to batch consistency will be there. Quick screening by trained panel before releasing into the market. Packaging and sensory perception. So color and texture, you see this kind of package. If you give this kind of package to people, they may not like this one. It looks very, bad. Some people may like this one, some people will not like. That's why the transparent packages are not recommended, right? Based on the product, you need to go with the packaging. Color and texture of the packaging influence the expectations of the product used in the market research and design. The sensory analysis will be indirectly linked with the packaging also. And then the next one is cultural and demographic factors. Taste preference will vary from region to region, right? So accordingly, you need to consider and design the product. Importance for global product launches, this particular cultural and demographic product we need to identify. Some products it will be liked in the North India, some products it may not be liked in the South India, right? Some products are liked in Brazil, some products we don't like. Right? Like that, depending on the cultural and demographic factors, you can go with the product development, right? And sensory evaluation. Sensory and shelf life determination defines end of shelf life based on consumer rejection. When the consumer will reject the product, that you can identify. That is the threshold limit. Correlated with chemical and microbiological limits, right? Then sensory labs, they are certified ISO 85,000, 89 sensory analysis. Guidelines are given. Some basic standard operation protocols you can see here, right? Instrumentation correlation also possible. Electronic nose is available, electronic tongue is available, texture analyzers, all these things are instrument. Supports the objective validation, right? Emerging trends. So this is emerging trend using VR. You will, ask the panelist to, give score for the product. Okay, instead of creating the sensory lab, you can give VR to the panelist and you can easily get the score. This is the emerging aspect. Some of the challenges, I know definitely the sensory evaluation is subjectivity is involved, panelist fatigue. Means if the panel, the condition, it depends on the condition of the panelist, right? So if he's okay, fit and is active, then he can give good score. The same person, same product is being evaluated, but is very tired, then he will give very less score. Cultural bias in consumer test, time cost of the panel maintenance is also very much important, right? So what are the key takeaways from this particular lecture? You can see you learned how the sensory evaluation is integrated with the food science and how this is important, right? It's very much important when it comes to launching a product in the market, or if you are going for reformulation or any kind of packaging decisions also. Sensory evaluation, it combines the scientific rigor with human perception. You know, right? Human perception is very much important. And if you identify what type of attributes are required for the human, in terms of what maybe consuming the product, that will be helpful for us, essential for quality assurance and product success. Okay, that's it for this particular topic, sensory evaluation and consumer acceptance. Somebody was asking doubt on QDA, right? I will quickly go through the QDA. Yes, this particular one, right? So quantitative description analysis. So if you are given any product, say suppose for example processed fish is given, based on the product the panelist will decide how many different types of attributes, sensory attributes, are involved with this fish. They say fishy flavor, odor, saltiness, spiciness. They will list it down. Okay, they list down each and everything. Then they will give the unstructured scale 1 to 9. What 1 indicates this particular attribute is absent. If the product is not having any kind of fishy flavor, then you will give 1. So similarly, for all the attributes, you will give the score, right? If the spiciness is there, then you will give 8 means very strong. So like this you will do, right? Am I clear? Yes. Now this session is open for discussion. If anyone have any doubts, you can ask me. So this session is open for discussion. Any doubts? Somebody was asking, in India, are there any sensory evaluation trainers? Is there any short-term course? Definitely, I know so many. There are not short-term course, certification programs are there. You can become a sensory expert by joining in those particular sensory. You have different types of agencies. Okay, for tea tasting, the different agencies are there. They train people on the sensory nodes. For coffee tasting. Okay, Coffee Board of India, Government of India, the Coffee Board, they give training. They have 1 year diploma course also. You can go. It's available in their brochure. You can see that one. It is in Bangalore. Similarly, for other wine tasting, it's not popular in our country, but for Europe or any other nation, this wine tasting courses are also being conducted. Okay. Any other doubts apart from this? Any participants? Any doubt? Anybody? If there are no doubts, I think you can proceed with the second session for today's course. I am available in the WhatsApp also. You can ask your doubts. I will clarify. Okay. I think should be we can conclude this session. Peace.
Hello, sir.
Yeah, peace. Yes, yes.
Okay.
You can conclude this session and you can start yours.
Okay. Thank you, sir, for your presentation. And I hope everybody would have learned a lot from the presentation. So moving on to the next session. So just a quick visual checks before I proceed. Is my audio clear and am I audible to all?
Yes, yes, yes. Your audio is clear, please.
Oh, perfect. So hello everyone. I am Piyush Sharma, the PhD research scholar at NIT Rourkela. So I am here with my limited knowledge on quality management systems. So till now, many of the speakers ahead me in the course have covered already a lot about the quality aspects of it, quality aspects of different processes, entire product, whether it is a process, product, or quality control perspectives of the food process change. But do we have any applications for that? And here comes your chance today to understand where we exactly are going to apply these quality perspectives into our food process chains. So I will be taking you through QMS very in very brief manner. We'll be understanding why we need it, what it is, and how we have to implement it. So, but before that, a quick disclaimer to all that the contents of these presentations have been drawn from ISO standards, BRCs, and from the Codex Alimentarius and other reference documents. And those all are either publicly available or have been properly cited wherever the informations or content have been drawn from them. Apart from that, if there's any other illustrations, I have duly accessed it from NIT Rourkela access points. So let us proceed with what is quality management system. And the moment we talk about quality management systems, why do we need one? We already have our product change. We as an industry, we definitely do care about our product, right? Why then we need a quality management systems in the first place? Many of you would have heard everyone saying that my product is number one. My product is best in the market. My products cannot be compared with the others. And many such statements have been made by different industries or the brands across in the market. But how do I, as a consumer, decide which one is exactly good, and why quality management system can help us in actually figuring it out? What exactly uh, the quality promises a particular brand is making. So let us consider one scenario to understand this. Why we need QMS? So let us consider the scenario that we have to make a muffin cakes. In the last presentation, the speaker have widely covered of the sensory perspectives, and in that one of the example was with the cakes. So let us draw the same example from the previous presentation and understand if a cake have been made by different workers, how well and how much standard deviation we are expected or we are probable to have when we are producing it maybe with one person at a time. Maybe you can say a particular chef is producing constantly that product, or if there is a process line chain without without QMS in place. So these are two scenarios. I want you to think here for 5 seconds and then understand in where we can have more standard deviations in the product quality. So many of you would have correctly guessed by now the standard deviation for the product which have been made by one single person, uh, that is that is the person. Okay, so something like this, a person which is made by a single person because he is well aware of the process what he is using across the entire process. So he is well aware of that. So the standard deviation is going to be lesser here. But when we have multiple persons in the process chain, everyone is not aware of what other person is doing, what quality standards other person is keeping on, and how what extent of it is actually followed, the proper procedure. So when we do not know these aspects, there are higher chances to get the standard deviation. And here comes our first concept of QMS, the concept of Six Sigma. What is the concept of Six Sigma all about? It is a simple concept. When there is a recurring process, and I want to stress it here, when there is a recurring and repeatable process, the standard deviation should be as minimum as possible, so as to ensure a consistent quality across all our products. Whenever, irrespective of the time of supply, our product quality should be consistent enough. So in Six Sigma processes, we generally talk about a million repetitions. Just a 3 out of the million repetitions should go wrong, and we essentially do not guarantee it should go wrong. We guarantee that maximum 3. Uh, you can say the product out of the million I produces in a factory or in a factory outlet can go wrong. So, or maybe the better way of saying it would be the quality might be slightly different, but we are guaranteeing that with the Six Sigma processes. And this Six Sigma processes are widely applied in the facilities, so as to the particular facility is Six Sigma certified, or we have Six Sigma certifications with us, and that essentially says that our processes are properly in place to as to ensure those these standard deviation to become as minimum as possible. So a one person can do the same thing. Other persons, we can train them to do the same thing. But still, do we have answered why we need QMS? The answer might be, let's suppose when we are talking about producing one cake or maybe a kg of the batch, it is very easy to manage the quality. But let's suppose in a facility, we are talking about producing 10 lakh of the products, 10 lakh of the muffins for say, in this example. So in those processes, when there is multiple batches of the production, multiple uh, you can say the shifts of the production, different workers, and still managing the same quality is a challenging aspect. And to manage that, QMS comes into picture. And QMS can be said as a controller of the deviation of our product quality, or maybe to improve the process efficiency of our product. So, well, the question for the company is, for as a pro industrialist, the company may ask it, I have my product, I do my quality standards, I do manage them, I have my consumer who trust me. Oh, I request participants to unmute themselves. Fine. All right, so let us continue. So we have my company. I was there at this point. So I have my company, I have my product, I have my quality standards, and my consumer do trust me. Then why essentially I need to go with different certifications body to certify me for something which I am already maintaining. So, well, this do sounds logical, but let us take this from the consumer perspective. So when I say consumer, do not restrict yourself to the retail consumers. Well, retail consumers are just like us going in any supermarket and purchasing a product. But well, the industrial consumer is something which is also covered in the wide arena of consumer which we are talking. So industrial consumer are B2B segment market. They are into B2B segment market, which essentially takes one product as to as a raw material for their own production process. And it goes without saying, if my raw product doesn't comes with a good quality, end product will not be of good quality. So the quality insurity needs to be done, and every industry to do these quality checks on every other industry isn't very much possible. So we do have certain international guidelines because our supply chains across the world is very much integrated. India do supply raw materials to several other countries. Several other countries do take our products and process and supply to some third country. So our supply chain is very much integrated, and then we need certain bodies like International Standard Organization ISOs taking a lead for one to give the voluntary standards for them. But depending upon the market, these standards changes. So let us a bit dive into B2B market, where the industry is actually chasing a standard. So they might be conducting certain, supplier audits before they purchase the product, and they know it very well that they have been ISO certified. But as to get the second certification, secondary audit higher than the ISO standards, they can apply for their own, for sake to maintain their own process quality. They can do supplier audits. We'll be checking one example in the end, how to do it, and how our plans suggest it to do it. At what point one should conduct the supplier audits. Not every time we can do it. It is very costly for the industry to do it, one. And to get the permissions to do it from the other supply industry, it comes at a cost. So industry do not run for it. Rather, they depend upon these standard organizations, and they chase the suppliers which have these standards with them. So there's some of the standards like BRC standards, ISO standards, US FDA. Depending upon the market to market, the changes. Let's suppose for US FDA, it's for US markets, American markets. For the Europe, and we have European standards for it. For the Britain, we essentially have BRC standards. So different market have different standards, and each B2B customer has to take their suppliers which follow these standards. And otherwise, there are many news in the market about the rejections we face every day. Our Indian raw materials are face rejections every day because we do not have these standards, and nobody believes us with it. Our prices go down. So these are essentially the problems when we do not have these certifications. So as a retail consumer, why I should worry about the standards? Essentially, there's no need to worry for us to worry about, because we have certain regulators that do this job for us, like FSSAI in India. And FSSAI internally conducts certain audits, inspections, to check whether the and facility to produce a particular product is been properly managing. Well, their standards are a bit lower than the BRC standards, but still, their main concern is for the safety, and quality depends upon the market. So these regulators do give certain regulations which are legally enforceable. So for the end of to make sure that retail consumers are very much safe when they use those products. Rather, the BRCs and ISO standards, they are voluntary standards. They are not legally enforceable, but they are informally enforceable. Per se, let's suppose if I am the supplier and I do not have the standards and nobody buys my product, then there's no point of me producing a product. So I should go with the certification process to essentially get this certification so that I can sell at my product. And second way around to think is, the moment I have one more standard added in my profile, it leads me to get and ask for the more price for my product. And well, whatever we have talked about, the inspection essentially goes with a process known as audits. Many of you who have taken some kind of internships, maybe have done some work or spent some time in the industry, might be very much aware about the audits. The FMCG audit and the season of December to March is an audit season where every supplier in India calls for a consumer audits, and many of our buyers come and take the audits for the Indian suppliers because that is the harvest season for us. So that's why audit is one of the thing. And certification bodies, as I said, they essentially ensure that our product is of consistent quality. And when I say consistent, it doesn't mean that an industry is not maintaining the consistency. It ensures that we are at base minimum level of consistency. Above that, it is always welcomed in the market. But that's why that essentially covers why we need the QMS system. Understanding this, then comes the next question: what is the QMS standards all about? Well, I'm drawing it directly from the ISO 9001 standard out of 2015 edition, which they have published. So let us see what they talk about here, of how they think about QMS. Well, they say the ability to consistently deliver the products and services that meet the the consumer and requirements along with the regulatory and statutory requirements. So a product ISO standards essentially covers the quality above the baseline level of the regulatory standards. So let's suppose if FSSAI, if let's suppose I have an industry in India and I want to supply it to US market and I want to get the ISO standards, that essentially means that I have to first pass the regulatory standard of my own country, the regulatory standard of this country in which I want to trade in, and then I have to maybe ensure the other standard specifications that is have been specified in ISO. That is the first thing that ISO talks about. We must meet the statutory and regulatory requirements, and the QMS system should help us to ensure that. The second biggest thing is customer satisfaction, but the customer satisfaction is a very broad term. In fact, ISO 9001 is a very generic uh, version of QMS system, and it is applied across the industries, and not only about the FMCG industries, but they have given their boiled down versions in their other ISO standards, which we'll be talking in a bit. And the third aspects which they consider for QMS is to minimize the risk and opportunities. Minimize the risk and checking out, maybe increasing the opportunities to ensure those risks are minimized. So, what are the risks? So, well, this is also a broad term. Risk for food is different, very much different. And we'll be talking in a bit what the risk mean in the product, in the food product and the food industry. But for a moment, try to remember that we have covered, we have understand or we have seen something about the risk, and we'll be talking about what the risk is all about. And then we'll be taking it out, the ability to demonstrate the conformity with specific quality management requirements uh, across the production process. And essentially, I'm using the production process quite safely for food industries. Well, those industries that do not have the production in their process, that it might come for their service delivery process lines. So these are generic words for that. But for the food industry, let us see what uh, specific ISO standards we have. But before that, just have a look how the QMS, how the ISO defines as a process. So ISO defines process as a combination combination of certain inputs. Those inputs may be of any variety. That we have some matter that is going on. That essentially means we have some raw material flowing in the process. We might have certain energy flowing in the process. Energy might in the food industry we might take, let's suppose the steam is flowing to sterilize, so that is the format of energy for us. We might have certain information flowing in there. That is information that might, you can see that we have talked about quality analysis of particular products. Let's suppose we have taken phenolic content, we have taken the color values, we have taken, so these are essentially the information of a particular material or the requirements essentially for the material, and those are well covered with the information aspects of the QMS. And then there might must be certain activities for it, and activities, many of you would have guessed already, these means processing for us, for in our food industry. There must be some process, streamlined process, flowing process, that takes a starting point, that takes a raw material and that gives the finished good product. If there are parallel processes which takes the independent raw material and gives certain output material, that might not be classified as a QMS. We need to get some amalgamation processes where there are connectivity in between the process, and that's why we are drawing our second process quality based on the first process, and then the QMS comes into picture. And then we must have raw material. Another can be matter, energy, information, and then we have receivers of the output that are essentially the consumers. And consumers can be of B2B segment and B2C segment. So we have widely covered in the previous slide what they all are about. So let us move to next slide. Okay, let me clear it down. Okay. Okay. So, yeah. So ISO let us to do the QMS system based on one cycle, that is one concept, or rather we can say that is plan, do, check, and act. And what is plan, do, and act, check, and act is first you plan our process. Which process will come first? Which process will come second? Which process will come? Process will draw its input from one process and just draw a connecting links between the process. And you can essentially take this for the food industry as a process flow diagrams, which is available in the industry. And that is the first diagram which you, while entering in the industry, must see it to check which process is linked with which process. And that essentially is described in process flow diagram. And we'll be seeing in one of the examples, uh, the process flow diagrams. And based on that examples, we'll be drawing out one, you can say the hazard analysis plan for this, but that will be at the end of the session. So essentially that is covered in the plan. We do have to do certain activities to implement what is planned, and then we have to check and monitor. Essentially, you can take it as a QC and QA monitors, and then we have to act. And act is something like if our process is not within the quality checks, then how I should ensure that they now follow the quality checks, and what are the conformative actions that I have to take to ensure that particular processes of particular maintaining the quality that I have specified in my process. The generic ISO standards specify PDCA cycles as shown in this slide. But before that, let me tell you the numbers mentioned in the brackets are not the random numbers; they are the clause. In which clause ISO specify those particular operations. Okay, so if you have to take, you can say the reference for a uh, particular process, you can essentially go to that clause. We'll not be covering each and entire clause, but we'll be talking out in a very brief manner. So let's suppose I have to certify myself for ISOs. Then what I should do in the first place? So first I should understand what my consumer requirements are. Essentially, I should understand what I want to guarantee to my consumer to ensure that I have a sustained market. And not only sustained market, I have a satisfied consumer market, rather say. So if I have first specified my consumer requirements, and when I have specified those consumer requirements, what are my plans to ensure that those requirements are met in our process? So there might be certain persons who will be responsible to for that maintaining that particular process, and that comes out to your leadership or senior management roles in the industries. So senior management role, is a center house that checks all the operations. So we have planned it out. We have to, you can say, do the operations in a manner like we have to process our product, and we have to essentially tell the second process comes, you can say that needs to be of certain quality requirements, so as I pass my product from second process to third process, and subsequently further into the process chain. Then I have designed my process. Then I have to evaluate it as well. So we have to give some evaluation metrics. Let's suppose if I'm sterilizing it, the particular log reduction must be attained, or the particular temperature for particular timing must be attained, and then I consider my product as a sterilized version. So that is how we evaluate it. And then let's suppose if my product doesn't meet particular temperature and the temperature doesn't reach, or there is a breakdown in the production process, then how I'm going to divert my production so as it doesn't pass again back to the consumer. So that is how improvement comes into picture. When we do not have our process standards met, what industry is going to take, what actions industry are going to take place. And many of the foreign standards, any time when a procedure fell down, or there's a standard that got lowered, we have to submit a root cause analysis report. So root cause analysis is something like, I know my product process got failed, and I very well know that I have managed not to proceed it in the form of finished goods, or let it. I have prevented it from flowing it to the consumer, but still, why the process got failed in the first place? And essentially, what are the aspects that went wrong to in the process, and that they have taken it to the failure. And that root cause analysis report is very much essential, to keep it back in the planning step, so that the next time these errors doesn't occur. So this is all about the generic version. Let us see a food industry specific version of ISOs, that is 22,000 and 2018 version. I'm drawing the content from. So we have already seen the plan, do, check, and act in the generic versions itself from ISO 9000. So we know what is plan, what we know what is do, we know what is check, and what we know what is act in the generic plan. But for the industry, how the operation looks like, and what are the specific standard that ISO 22000 specifies, and that quality management system needs to work for, or what essentially the quality management system for food industry must look like. So we know we might have certain plans. Plan might be to take a product A, process it with some kind of process it with some kind of you can say processing steps. And that maybe may take it as process C or D, and then get a finished good of certain quality aspects. We then in between we have operation step. We have to take it through certain process, and those process are our operation planning. That is like we have to we have to first decide which process, how process flow should be there. We have to decide what essentially the risk mean for us. And in the previous slide, I have told you to just recall from our previous slide that we talked about risk in the generic plan of 9000. So the risk essentially is the hazard control plan for us, or maybe the hazard analysis for us. What kind of hazard do exist in our systems? Maybe we can take it from here. The hazard analysis are there. What are the validation process? What are the control process are there? And if at all the hazard exists in the system, do we have plan to control it? And then we have two plans generally, HACCP and OPRP plans. So many of you might already know these plans, but let me cover it brief. Hazard analysis critical control point tells us that if I have process A and I'm giving process B and I'm taking process C before getting my finished good, and RM comes into process A. So hazard analysis critical control point simply says that if there is a hazard at point A, let's suppose there is a hazard exists at point A, and then the same hazard exists at point C as well. But then the critical level would be considered as C, because after C, there is no more control with me in the process to control that particular hazard, or to check out if anything goes wrong. I cannot control after process C. So it might be a point of control, but these point C or process C will be our critical control point, or CCP, because there is no control after that, after the process C. So we'll be seeing it out in a process diagram, a process flow diagram for a particular industry, food industry, and to essentially understand where all the control points can come and where all the critical control points come. Then what essentially is the second one? OPRPs. So I know my critical control point falls at point C, but should I leave the process A as it is? rather than I know I can control at point A, but how do I essentially ensure that I've controlled at point A? And there comes the second version, that OPRPs, that is operational prerequisites for us. Let's suppose I have a sterilizer at the end, and before sterilizer, maybe I am giving a certain other heat treatment as well. So I know I should ensure that my product reaches a particular temperature in process A, so that by the time process C comes, I need not to give it heating for longer times. And essentially, I am preserving my quality of the product, which is one of the aspect in the QMS systems. So then I should ensure that there must be certain OPRPs in place to ensure that particular temperature reaches at point A. If at all it is not reaching at point A, I might reprocess it, or I might divert my production process. So these are OPRPs and HACCPs that is essentially there in the process to ensure that particular hazard is being controlled. And right now, in the example we were talking about the microbial hazards. We might have physical hazards, chemical hazards, and a lot other varieties as well. So, and that the complete system that includes these all, along with the traceability system. Let's suppose the process even fails at C. Our process is very good. We have ISO standards. We have Six Sigma with our industry, but still we can face some failures as well. Then we must have a system to recall our product, and that concept is of traceability. Like I should trace each and every product sent to the consumer. If there should be certain mechanism to identify if the wrong product or any product reaches to a consumer, I can trace it back to entire production cycle. I can trace it back in which batch it was processed. I can trace it back how much quantity it was taken in the raw material, what was the essentially the steps or the process steps that have been taken. So these four you can say process includes in ISO standards. And again, regardless, saying this, these are the voluntary standards and these are the basic baselines for us. I can set up certain more ORPs in process B also. I can set up more ORP. Maybe I can divert it with maybe B star process. Maybe we can take another process for diversion, and I can ensure even more quality for my process. But ISOs, this says that minimum basic, these things needs to be there. So this is all about ISOs 2000. So understanding, we have till now understand why we are doing it. We have understand what it is. Let's now cover how I should do it. Let's suppose I have an industry and my factory produces certain product that I have to supply it, let's say to America or in the US market. Then what essentially I should do it. So the first thing is I should pass my inspection, that will be by the regulatory bodies. And then these are compulsory binding regulations I must follow that I have already covered. And then many of you would have this question in mind, that why it is up to here. ISOs, we have already told, as I've already mentioned, these are voluntary standards. They are not legally enforceable. Then why essentially we are keeping these standards in the compulsory and legal binding standard for India? The answer is very simple. FSSAI draws a lot of standards from these draws lot of make or draws lot of standards from these international standards. Let's suppose FSSAI says you must comply with ISO 22000 maybe to export, or you must meet these requirements so as we legally certify you in India to get to start your production process. So they essentially are covered there, but each one of them are internationally voluntary regulations. Some of them are some of the standards from these have been taken by the regulators, and therefore to ensure that we are getting our facility uh, approved we have to follow these regulations. The QMS, as for now, uh, in the example which we are taking, and I'm drawing it from a research paper, and that is essentially for not for the Indian market, and an Indian market also. Many of the facilities, FSSAI doesn't legally bind it for us to have QMS systems in place. They just say we must have certain product standards, but they do not say, uh, as for now, we must have certain QMS standards, and we must have, uh, essentially, you can say, the process, particular managing the quality of each and every process at present, and they are the voluntary or the guidelines. They're just the voluntary guidelines for it, and they are not the legally enforcing laws. So there's a difference between them. So we have our product standards, and many of my previous speakers have covered. Let's suppose certain colors have been not allowed in the product, so that is one aspect of the quality that FSSAI takes it as a product standard. And what today we are talking about, the facility or the factory standards, that comes essentially comes in the QMS. So those are at present are under the suggestions, as a suggestions and the guidelines, but not a legally enforceable guidelines. We might see it maybe in the future, but USA, European markets do have these guidelines. So, but if I have to float my product into the US market, then I should comply with the regulator in India as well as regulator in US. And that's how, no matter if in India it is not, it is voluntary or suggestory one, I must follow this so as to get my food inspections cleared, or maybe my inspection clear at the port when my product reaches the US market or US port, for you can say. So these all standards have been classified as sub classification have been given. Certain standards are for basic food hygienes, that is GMP, GAPs. Certain are essentially for food safety, that is HACCP standard. Certain are to maintain the food quality, promising food quality, because ISO 22000 says that if you are promising a consumer a particular quality, but you must ensure that your processes are in place to satisfy those requirements. And a QMS system is taking all over coverage, ensuring traceable 100% traceability of uh, traceability of the product, tracing it back to the production cycles as well. So these are the standards and legal specifications. But let us take now one case study scenario to understand whatever we have talked till now. And but let me, before I take you to the document, let me just brief out you what scenario we are considering. We are considering there is a wheat flour milling facility, and that might have to target US market for its exports. And we are talking about a production facility that is producing around 1 ton per day. They are operating in 2 shifts, 8 hours each, in 6+2 combination. That is when 6 hours production and 2 hours of the cleanups. So, do not get confused when I say 6+2. The production runs for 8 hours only, and how it runs is, let's suppose I have processed. I have processed. Okay, let me draw it big diagram for you. So let I have raw material that is passing from process A to process B to process C and to process D, and before it comes to the finished good product. And essentially these processes might be sorting out the wheat quality, maybe grading, sorting, grading, maybe milling or sieving. So these are the essentially the process. And in my facility, I have I have separate facilities, sub facilities for these processes. And let's suppose I have to take my sub facility A to the cleaning, and I have to ensure that my production process is flowing properly. Then I can run down the production in process C sub facility, keeping ideal process B and A. A is in the cleaning, B will be the ideal, and then C and D will be running down the production. And then when I have to move A, then the C should be idle and D should be in processing, and B will be cleaning and A will be again idle. Then when the process moves to cleaning of D, then A can start, feeding out the section. Maybe the feeding section can start the producing the next batch and the process for the next one. So essentially, we are operating in 6+2 combinations, keeping one thing in an idle and still giving an operating hours of 8 hours per shift. So that is essentially 16 hours of production in a day. A lot of the export facilities run 24/7, but for the simplicity of the example, today we are considering we are just taking 2 shifts and of 8 hours each, and every process has been designed with proper, you can say the machineries that can handle that production. So, and if I'm taking 1 ton per day, and day consists of 16 hours in 2 shifts, so I'm essentially want to do 0.5 tons production in one shift. So that is what we are looking, and we'll be checking out for to manage this much big production. If anything goes wrong, our properly completely the product will be wasted. Essentially, in any cycle, if it fails, let's suppose if the process quality standards fails at sub facility C, then our complete product which have reached process C must be diverted into the rechecking section or maybe reprocessing segment. That essentially involves the cost. And one thing industries are well aware of, the cost of production needs to be minimized, and these are like everyday problems for them. The cost is increasing high, cost is increasing high. We have to ensure that our product quality management systems are in place so as to ensure that there are no substandard processing of any product. So, but before that, as I've already mentioned, we have to first look the process flow diagram of any industry which we are talking about. So let me show you today uh, the industry which we are talking. The process flow looks like this. So, but before that, let me clearly mention this. This is the diagram from ABC Machineries in China. From China, the industry exists in China, and they are following the requirements. They have their clients from US. So I've just drawn the publicly available content from their website, and so none of this is a proprietary content. So it is a public content, so we can discuss it outrightly. So let us see our any production starts at the raw material intake or raw material upcoming of the raw material in the facility. So the raw material comes out to us, and then we are intaking the, maybe let's, because we have to produce the wheat flour, so we will be taking the raw material as wheat flour. And in this process, to keep it simple, I've taken a unidirectional process. That means process is flowing from process A to process B to process C, and there's no coming back, and there's no additions from anywhere else. Means at the process B, there is no other ingredients that have been added out. So for simplicity, we are taking just a unidirectional process, but industries do have the other processes. And in each process, let's suppose if any ingredients are going to add in this facility B, so this will be one more process in which QMS needs to be maintained. So so like that, if there are any additions across the sub facility in a production process, then QMS standard must be maintained at each of the particular facility. But today we are just talking about a unidirectional process for producing wheat flour. So we have taken the wheat here. Then we will be separating. We are doing magnetic separators to check it out whether there is any you can say ferrous you can say the contaminants, iron or magnetic contaminants that is present, or to separate to essentially separate all the you can say the extra impurities which is iron based, because we are going to take it into the mill, and any ferrous any ferrous impurities or any ferrous, you can say the extra material which is present, can disturb our mills and can damage the machinery. So we have to essentially ensure that there is no uh, uh, it is properly separated and it is being taken care of at this step. And then we are taking it into the separators, maybe taking it into the wheat bins of particular quality, because when we are running down the mill and we have to ensure the flour production is at its peak, so we have to first segregate it, sort it out based on different varieties of wheat, different weight of the different weight and density of the each grain. So we are doing that. And then we are just taking any kind of lighter impurities are there, so we are just aspirating it, maybe we are just blowing the air so that the impurities get away, and let that is there. And then the next we have dampers and the tempering bins. Before milling, we give them so as to attain a particular moisture content. Our moisture content in the finished product is maintained properly. We have certain tempering bins, and then again we have aspirators after that. So we have aspirator 1 and aspirator 2, so you can easily understand which one will be the control point, and if there is another aspirators or magnetic separators at the end, so which one will be considered as a control point and which one will be considered as a critical control point here. And so these is the process flow. And we then have the milling, the first break, which is many of you are aware already, and I'm not going into the process, essentially the process flow of that, uh, the wheat flour production process. But you have the first break, second break, and third break. And so these are done with certain kind of rolls and milling units. And then we have to collect the flour, and then we have to take it out, brand from it. Essentially the floor bins will be there, and then it is again going back to the final redressers that can segregate into flour brand, and other you can say impurities is there. And flour is something which we are supplying, in which are supplying to our you can say the consumer. So this will be our finished product, and those others two in the process, that might be, you can say, they are the additional you can say additional product which we get out from this process, but they are not the finished good, because our aim is to produce flour. And uh, then we have to pack it. So we have then packaging unit is there, and we have to store it. So this is a basic you can say process flow of that particular industry. And let us now move to understand and check, if at all the process looks like this, then how I should implement QMS or HACCP plans for my this facility. So I will be taking a moment to share the document, and the document which I am showing you, it is taken from FSSAI, and it is also publicly available for you to view it. So let me take a moment to share the document. Okay. Okay. So I think the document is visible to all, and let us proceed with this document. This is a draft document given by FSSAI, and this is essentially a guidance document. And I, as already mentioned, these are the guidance document and they are not legally enforceable documents, but FSSAI do recommend every facility to have, you can say, this particular this particular document serves as them the guidance for implementing QMS in India. So we are just drawing directly from this particular document. So let us quickly run through the documents. And as I've already shown you the process flow, the process flow essentially looks like this same which we have seen in a factory process for 1 ton. So we essentially have separators, aspirators, and then destoners before taking it to the brick mill, like to the milling unit, and then sieving it, essentially producing the wheat flour, which is one of the product for us. So the process is same. So let us now look into this. And this is one of the important thing. Many of you would have already known that we have to allot critical control points at each and every process. To in each and every process, we have to ensure that whether this is a particular this process comes as a critical control point, whether this comes as a control point, and whether I should apply the prerequisite programs for it, or whether I should apply the OPRP's program or a CCP programs for it, or HACCP is anyway separate. So let us look into this, and I suggest all of you, because we will be referring to this particular page and these particular metrics for our product, for deciding the process of our processes, whether they comes under PRPs and OPRPs. So I request everyone to take a screenshot and keep it for the time being, because when we are scrolling it down, you might not be able to see the metrics again, but every time we will be referring to the same metrics. So it is essentially the metrics they have the two components for the metrics. What is the severity of our process and what is the occurrence of our process? And based on my slides, you must have already taken this takeaway that we are implementing QMS in a recurring process, correct? And when there is a recurring process, we need to ensure that if the particular process is a recurring process, and how probable I am to meet a particular hazard standard with that particular in that particular process, how probable I am to meet those particular hazards. And if at all I meet them, what is my severity if at all the particular hazard occurs in them. So let us first understand the occurrence. So occurrence is very simple. So if I'm very certain that a particular hazard will occur in my product, let's suppose the presence of E. coli in the wheat flour, or the presence of salmonella in the E. coli, or maybe the presence of foreign material in the wheat that we are procuring from the farmers, and the likeliness is very high, because we all know that we are producing the wheat, essentially wheat after harvesting is kept in the farm itself, and there's a there's a for likelihood is much more that the contact with the soil will be there, and the moment the soil contact with the soil is there in India, it is very much there's high probability that we'll encounter E. coli or salmonella in it. So the probability for them will be lying very high, and similarly we will be proceeding from certain to almost impossible, and the multiplier has been given by FSSAI as 5 to 1, and this is just a matrix multiplier, and we'll be taking the multiplier of our occurrence to the severity of our occurrence. Let's suppose what is severity of any occurrence? Let's suppose if my product, wheat flour product is there, if our wheat flour is there, the moisture content, the company or the supplier is guaranteeing 9%, and today the moisture content occurs at 10.5%. So essentially there is a quality mismatch, but the severity of this quality mismatch is not high, because even if it is 10.5%, I am ensured that my product still remains shelf stable. And because it is less than 12%. So the severity will be very low for them. But take it as otherwise process. Let's suppose we have a coliforms or E. coli, presence of E. coli or salmonella, and that to Shiga toxin one. So the severity will be very high because there are high chances of hospitalization in a case if at all the product flows to the consumer hand. So the severity is very high. So if I am taking microbiologically one, that is severity of presence of E. coli and the certainty of E. coli, that will be 25. And if it is more than 15, then it should be a critical control point. That means I need to apply certain processes, like suppose sterilization or maybe decontamination, to ensure that this have been sorted out. So that's how we determine each severity of the process, to occurrence of the process, and to the level which we are going to take which we are going to take in our process. So let us see the second matrix, which is very important, and then we'll quickly run through the document before we end the session here. Uh, so when I understood these control measures, what are my assessment criteria? So assessment criteria is something, let's suppose, so which it had been given based on the uh, seven principles or seven criteria that we have to check whether we have to assess whenever we are going to assess our uh, whenever we are going to assess our product for the severity and occurrence. So let's suppose we have identified a food hazard, and we cannot eliminate it completely, or we can eliminate it within the certain level. If there is low severity, let's suppose we are taking a cocoa powder, and cocoa powder, the standard the regulatory bodies do allow certain foreign material presence in it. So we have to reduce it within the acceptable level. We need not to completely eliminate it. So it depends upon a thing, which kind of hazard which is there. Let's suppose if it is coliform or the toxin one, then we have to eliminate it completely. So like that way, everyone has been given one score. So the feasibility of monitoring, let's suppose if I'm running a steam sterilization process, and at the end of the process I cannot monitor the temperatures, though we have certain monitoring process via thermocouples, but I cannot ensure each and every product temperatures have been noted down. So there might be certain feasibility constraints with us. And let's suppose we are doing microwave sterilization. So essentially, I cannot, monitor the temperature inside the process. I have to simulate it, and industry and the regulatory bodies do give us, you know, uh, you can say the flexibility to do that, and that's how the comes is like whether it is feasible to monitor a process or not, and if at all it is feasible, what is the severity of the consequence, and what is the likelihood of the failure of a control measure. Let's suppose if there is a magnetic one, and if there is one magnet that fails out, then essentially there should be magnet B in the same control point if it is a critical control point. So if at all, likelihood of failure of one magnet will not lead us to the process failure. And that essentially I have covered that every process failure will count as a loss to the industry. So this is the metrics there. And one of the essential thing in this is point F. If at all there is a control measure that have been already established practice in the market, so we cannot, we cannot take it like if there is a definite procedure, then definitely we should also apply in our facility, and that is has been given by the point F with the the score of 3, that definitely it should be applied. So the score of addition of these assessment parameters will tell us whether it should be an OPRPs or CCPs. So these two are the metrics that we will be taking into consideration when we are now proceeding ahead in the document. So I request everyone to just take a quick screenshot of these two, and I will be quickly running through two of the process out of the entire process line, so as to give you an indication what will fall in PRPs and what will fall in CCPs in the quality management systems. So okay. So let us see, we are receiving wheat, that is our first process. And as I already mentioned, there might be physical contaminations, microbiological or chemical. The physical one is represented. The severity of occurrence has been given and the frequency of occurrence. And these are based upon, our suppliers. Let's suppose if I'm not buying it from the farm directly, I'm buying it from a third party supplier that essentially takes care of the foreign material, then my severity can be low because I am ensured that my supplier follows certain standards and have already taken off care of these problems. So essentially the severity will not fall too high. So we can do some prerequisite, and prerequisites can be the supplier visit or year of site. So that is a customer audit that I was talking about in the first place, in the second or third slides. So essentially these things can be maintained. Okay, so let us now go to the second aspect, that is chemical, the pesticides residue. If I'm essentially getting it from a particular supplier that checks all the aspects of the pesticides residues, maybe heavy metals, so I can essentially just bypass. For me, the severity can come low. But if I'm purchasing directly from the farm, then I should ensure that the pesticides residues have been, at the proper level before I supply it to the other facility, or to the my like I float it to the other market. And at present, in present example, we are considering US market. So before I take it to the US market, and to avoid the rejection in the port, in the their port, so, or facing any import rejections at America, so we should essentially control these uh, right now in our facility itself. So that is another thing. So these two are the major controls, the things that is there. The third one comes is biological that I was talking about. So many of you would can ask the contamination with E. coli is there. E. coli is there or salmonella is there. So do I have checked my product before? So another thing is in this particular example, there is an external supplier from which we are purchasing. We are not directly procuring it from the farm, and supplier has the control processes in place. So we need not to worry about the E. coli and salmonella at this stage. Rather, we can just do a customary audit before every year, or maybe some random customary audits can be done to ensure that our product, the raw material which we are taking from our supplier meets the particular standards. But if at all I'm taking it from the farm directly, then I must have certain decontamination process in place, certain fumigations and decontamination processes in place to ensure that these controls have been taken care of. But at present, because I am taking it from supplier, my severity and frequency will be very less, and then it will be just falling under the PRPs, that is prerequisite programs for the facility. So this is one thing. And similarly, we have other for the packing materials, and for the other thing, packing materials kind of inspections I do for the facility. And the biological, the storage facility in which I'm storing my packaging material. So, and I'm definitely, because industry do not produces each and everything by themselves. They have their suppliers in place, and when they consider buying a product from a particular supplier, they essentially do take care of these standards and assessment levels. So these all things fall in the same place. So let me take you directly, skipping out these things, that let me take you to the CCP level which they have taken. So, okay. Okay, so there at the destoners. Okay, so let me just take this quickly. Destoner is there, and destoners involves machines having mesh. It might be of stainless steel or something, but a piece of mesh can be broken, and like after continuous usage of a product, if their maintenance is not in proper order, they might break it. So there is an additional step. uh, though our foreign matter is not present initially in our product, but essentially it can come from there. So we have to ensure that our process conditions are right in place, and there might, because there is one step that can add hazard in our process. So then there must be certain other control points in the further in the process to ensure that if at all it exists, and the product doesn't flow to the consumer. So, okay, let me clear the drawings. So similarly for surface cleaners are there. So they all are coming under PRPs because we do have, control ahead in the process. So yeah, now I want to talk to you about the magnets which we are talking about. The first magnet that comes in the process, like we were talking about when we are, you can say proceeding ahead with our product and keeping it into the silos for further processing, or maybe the intermittent processing silos, then there is a magnet, but it is falling under PRPs because there will be certain another magnet will be there at the end of the process to ensure that even if we miss, if certain impurities or foreign material, ferrous foreign materials miss out with this magnet, we have certain other things in place to check out the control or to manage the hazard in the further in the process. So this magnet, though it is very much critical, but it is not a control point. It is not a critical control point for us because we have further controls in the process. So let me take you to the CCP. Yeah. So now, so we have the final sieve here. We have seen one sieve ahead, de-stoners and sieve there, but this is the final sieve. And if at all my product, if at all any foreign material passes from this sieve, it is unlikely that it is very unlikely that I am going to control it in the, I'm able to control it further in the process. So this is considered as the CCP, and the severity is very high because, as I mentioned earlier, our processes are there that can add the foreign material contamination, though it might not be present initially in our product, but they can add it up. So the final sieve must be in the severity of occurrence, and if at all there is an occurrence, it would be high. The severity will be very high because it is directly going to the consumer now. So it will be a critical control point here. So yeah, so proceeding ahead with the document to check whether there is any other CCP control points. Okay. So as I've already mentioned, I'm repeating it again, like there's a magnet now and which is coming in the final segment. So it is considered a CCP. So because we have many mesh products involved and many, you can say sieves are involved, and there might be damages because milling generally occurs, throwing, particular the product at very high density, very high weight falls on the sieves and it might damage the sieves. So there are high chances of occurrence of some foreign material presence, in the there are high chances of that. So, or we are not telling that it will occur, but there we are just estimating the chances of it occurrence, and if at all it occurs, what is the severity, and then we take it to we consider the final magnet as CCP for us. Okay. So this is another critical control point, and then we have to pack it. So they are coming in the PRPs category because we have already taken care of, in the process. So this is one of the, you can say, the control plans or hazard control plans developed for an exemplar industry, that is for wheat flour milling industries. The PRPs we are talking about is essentially taken care of by the inspection list. So there are certain, you can say, internal audit. Those inspections in the industries have been classified as audits. So we do conduct certain audits with them, just as like internal structures, they have been properly made, whether we have an updated license with them. Updated means whether we are following any other regulations that have been, right now enforced by FSSA or any other regulators. And all these things have been, taken care of. Like windows needs to be kept closed, otherwise any other insects or foreign matter can come the moment the products come in contact with, you can say, the product comes in contact with the foreign material. So likewise, we have certain um, inspection list that is maintained, and sanitation's personal hygiene. Those who are handling the production process must follow certain, you can say, basic hygienic practices, and not only hygienic, the compliant practices for their own, for the process safety sake. So like that we do it. And whether there's training or complaining, like that we calculate our score, and out of the total scores, we you can say check what is the ours score of our facility, and then how we can grade it ourselves. And this is the grade given by the FSSAI. BRC have certain A grade, and then B grade or something like that. So BRC have different grading systems. So we essentially in India classify it as A plus, A, B, no grade. So they are just four graded system, and BRC have more exhaustive, grading system, and that is like followed in the Britain. Uh, Voluntary standards, that is for the Britain market. If at all we are chasing United Kingdom as our market, so we have to go with you can say that particular standard. Okay, so this is there. So this is all about the inspection document and the things which I want to cover from this document. This document is publicly available on the FSSAI website. You can view it, or if you at all you want, you can download it and you can check certain other uh, aspects which is available to them. So just proceeding with just concluding my talk, so that we have now seen that QMS are essential for product safety and consistencies. We have to integrate with the global standards to ensure consumer confidence and to ensure that our process is sustainable enough to ensure to supply it to our consumers and to meet our consumer requirements. And these are my references, and you can take any of the guidance document can be seen, or the links which I have mentioned. Okay, so I leave now session open for you can Q&A sessions, and if at all there's any doubts, you can certainly ask for. So, yeah. So if at all there are any doubts from the participants, you can ask from me. You can either keep in Q&A section, or you can anyways you can mail me also, or you can keep it in the WhatsApp channels which we have, or you can alternatively you can keep it in the chat box as well, or you can raise your hand and you can speak also. I think we do not have any questions now. Yeah. So thank you everyone for joining. I guess the second session comes over. It have been a bit extended. So we'll be meeting at 2 o'clock as our scheduled time for forenoon sessions. So thank you all for joining. Thank you.